Thanks for checking out our vector calculator for mathcelebrity.com. You type in vector. So here's everything we have up to this date with respect to vectors. The lesson I'm going to cover is this lesson here. And if you have two vectors, A and B, you can do all these things. We click the vectors link. Here's the calculator. So here's how you enter your vectors. You enter one item per line, and then the return key, and then the next item in the vector. So for this particular calculation we're going to run two vectors, 1, 4, 9, and 3, 5, 2. And you can press any of these buttons. So we'll go through each one by one to kind of give you an idea of the functionality. So we're going to press this one first, the magnitude of A. So this basically calculates the length, also known as the magnitude of the vector that you entered A. So here's the formula. We simplify it, and then we get our distance. You can do the same thing with vector B. Press B, goes through the same formula, simplifies, and grabs your answer. Now we can do A plus B. So we'll add our two vectors. The nice thing about this is it lights each vector up in red and blue so you can kind of see how the math works. A1 plus B1, A2 plus B2, etc. So we add each respective term in the vectors, simplify, and then we express it in vector format. We can do this something similar, A minus B this time. Subtract the respective vector amounts and get our new vector. We can do A times B. We got A1, B1, A2, B2, A3, B3. And again, they're color coded so you can kind of see where you're at. Simplify the math, and here's the answer. You can press distance. So this is going to calculate the distance between the two vectors. So we use our formula here, simplify, and get our answer. We can calculate angle theta between the two vectors. So here's our formula, dot product of A and B times the magnitude divided by the product of the magnitude of A times B. So first we calculate the dot product. It's 41, which if you remember we actually did on this A times B button. And then we calculate the magnitude of A, which we did on the magnitude of A button. Magnitude of B. And then we set up our formula. Dot product divided by product of magnitude of A times magnitude of B. We get our angle in radians, and then what we do for is we convert to degrees, and here's your angle. Try the unit vector next. The unit vector is just your vector divided by your magnitude of that vector. So again, we've calculated this magnitude a few times now on this calculator. And then what we do is we set up the vector divided by the magnitude. Do relationship. So what this button does is checks to see if A and B are orthogonal, perpendicular, parallel, or they're going in the same direction. So we calculate our dot product, in this case 41. It's not orthogonal because the dot product's not 0. If it was orthogonal and the dot product was 0, this was changed to orthogonal. Our same direction test. So we run through the magnitude of A and B. And since the dot product is not equal to magnitude A, magnitude B, the vectors are not in the same direction. And finally, the parallel test. Here's the formula to run that test. So we break out each piece and then do the comparison. Because they're not equal, they're not parallel. We'll do Cauchy-Schwarz. So here's the inequality. And then we rewrite our vectors in terms of coordinates. We get our dot product, A times B, is 41. Magnitude of A, we've done that a few times. Magnitude of B. And then we demonstrate the relationship, the Cauchy-Schwarz inequality. So we show that, yes, 41 is less than or equal to 53.037. Finally, our projection button. So we're going to calculate the orthogonal projection of A onto B, and the vector component of A orthogonal to B. So here's the formula to project. Scroll down here in the math. A lot of this we've seen already. And here's our numbers. And then here's the projection of A. The projection of A onto B. And the vector component of A orthogonal to B. We also have a generate practice problem button. You've seen this on if you watched our videos. You press this button once, it generates a random 2 vectors. These are 2-dimensional. You press it again. This time it was 3. Press it again. This time it's 5. So we kind of randomize the dimensions of the vectors. And when you press this, you can run any of these buttons on the new generated vector. It's pretty cool because you'll never run on a homework or practice problems. We also have a vectors quiz. For more information on how to run that, use the video link under this folder. If you got any more questions or enhancement suggestions on this lesson or our site, please use the Contact Us link. Thanks for watching.